Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. In continuation to my sessions on CMI and ISI preparation, which are also helpful for JEE Advanced, today I have brought few good questions, very important question you can say on solution of triangle, where I will be using few properties of geometry also. So let us see what are these questions. We are given that in a triangle ABC, if medians drawn from vertices B and C are perpendicular, then the value of cot B plus cot C cannot be. Okay. Now here I will make use of some property like F is a midpoint because CF is a median. So this length AB being C, I can say this will be C by 2 and this will be C by 2. Similarly, E being midpoint of AC, I can write this as B by 2 and this also as B by 2. Okay, now if I call the length BE, the median passing through B as L2 and length of median passing through C as L3, and because their point of intersection is centroid which divides the medians in 2:1, this length BG will be 2L2 by 3 and this GE will be L2 by 3. Similarly, the CG length will be 2L3 by 3 and this GF length will be L3 by 3. So if I use Pythagoras theorem in triangle like BCG, okay, BCG if I use, it will be 4L2 square plus 4L2 square by 9 plus 4L3 square by 9 is equal to, and this length BC is nothing but A, so A square here. Okay, similarly if I use the Pythagoras theorem in the triangle CGE, then we will get L2 square by 9 plus 4L3 square by 9, and here we will be getting B square by 4. Okay, that is my equation number 2. Similarly, another triangle BGF, if I use BGF, so this will give us 4L2 square by 9, 4L2 square by 9 plus L3 square by 9, and this comes out to be equal to C square by 4. So this is my equation number 3. Okay, now if we add equation 2 and 3, we will get on the left hand side 5L2 square by 9, 5L3 square by 9. And if I multiply first one by 5 by 4, then also we will get 5L2 square by 9 and 5L2 square by 9. So what I am suggesting here that we add 2 and 3 and subtract 5 by 4 times equation number 1. So my left hand side will get cancelled and we will be getting B square plus C square by 4, and this will be equal to 5A square by 4. So one very important result we have obtained, which I will write on the next slide, and that is B square plus C square is equal to 5A square. Now this result is actually consequence of that two medians passing through B and C are perpendicular. So whatever else we are going to do, but I think this has to be used in at some place. Okay, so let me call this as equation number 4. Now to find cot B plus cot C, so one important observation here could be that this cot B plus cot C, cot B will be BM upon H using simple trigonometry, because this AM is the altitude on this side BC. So BM upon H, and cot C will be CM upon H. So if we add them, we get this to be A upon H, because BM plus CM will be complete length BC, which is A, so A upon H. So let us call this as equation number 5. So basically we have to check what this A upon H could be, and to do this thing, what I am going to do, I will use this BM length, which is actually, if this side is C here, I can call this as C square minus H square, and if this length is B, then the CM length will be root over B square minus H square. So I can write that b square minus h square plus root c square minus h square is actually equal to a. Okay, now dear all, please remember that we do many inequations like am greater than gm. So there we have one more inequation, that is rms greater than or equal to am. Okay, and equality happens always when numbers involved are equal. So here what is RMS? If I take RMS of this left hand side, okay, if I take RMS of this left hand side, it means I'll be doing the squaring of both and adding them, taking their mean and then taking their root, that is the root mean square, and that will be greater than or equal to the AM of these two numbers. The AM of these two numbers will be just a by 2 because their sum is a. So the mean of these two will be a by 2. I am repeating, I have taken RMS of root b square minus h square and root c square minus h square, and then I have taken AM also of the same thing, but I have taken this sum as equal to a. This thing will give us one very important result between h and a, b and c, you can say. Now doing both sides squaring, so we will be getting b square plus c square, which I can write as 5a square here. So 5a square minus 2h square in the numerator upon 2, and that will be greater than or equal to a square upon 4. Okay, so if I multiply by 4 both sides, I think here it will be multiplied by 2 only. So we get 10a square minus 4h square, and that will be greater than or equal to only a square here. Okay, so this will give us, because we have multiplied both sides by 4, so this will give us a square to be greater than or equal to 4h square by 9, which means a will be greater than or equal to 2h by 9. And here equality will happen when this b and c are equal. Let me write it here, equality, which you can check, and in fact many students think that way only, that this minimum or maximum whatever it will come, it will be when b and c are equal. Okay, and then also there will be some scenarios when these medians will become perpendicular. So equality only if b is equal to c. In fact, if b is equal to c, then a will also take certain value. I think this will take value as b into root of 2 by 5. So that is also a valid value for a triangle, you can check. Okay, and if a is greater than or equal to 2h by 9, then using this equation number 5, I think we get this cot b plus cot c to be equal to a by h, which will be greater than or equal to 2 by 9. I think I have made a mistake here. It will be 3 here. Yes, it will be 3 here because this under root I have to take. So it will be greater than or equal to 2 by 3. So this 2 by 3 is a possibility. They are saying cannot be. So less than 2 by 3, that is 1 by 2, minus half minus 2 by 3, they are not possible. In fact, cot b plus cot c will always be, you can check for any triangle, maybe right angle or obtuse angle triangle, it is always a by h, and a and h both are positive. So minus half or minus 2 by 3 was never a possibility. So they will be answer for sure, but our purpose here to find the proper solution, proper method. So only C is possibility if B equal to C. Otherwise, that will also not be possible. So here answer will be A, B, D. Okay. Now coming to next question. Here we are given that a triangle ABC and a point P here. Let me put it here. Okay. An internal point, if line passing through P parallel to BC intersect AC at M, and similarly line through P parallel to AC intersect AB at N, and line through P parallel to AB intersect BC at L. Then we have to find the minimum value of LC upon BL, MA upon CM, and NB upon AN. So basically these numbers which they are going to divide these sides into what will be the minimum value, maybe by some option putting, or I should say objective method, by taking points exactly lying somewhere in between, we may find the value. But I will like to discuss proper method that how we can do it. Okay, now to do this question, what I'm going to do here, I will take BL as a lambda times this opposite to A, this complete length BC will be A, so I will take this as lambda times A. Okay, so this LC will become 1 minus lambda, LC will become 1 minus lambda into A. Okay, let me write it here. LC will become equal to 1 minus lambda times A, because I am taking this as lambda A. Similar to this, I will take CM, C to M length to B, which is actually some portion of complete length B. So I will take this as mu times B. So CM is mu times B. So MA will become equal to 1 minus mu into B. And similarly, AN, I'm going to take this as nu times C. So this NB length will be equal to 1 minus nu into C. So what we are looking for here is actually 1 minus lambda upon lambda into 1 minus mu upon mu, okay, into 1 minus nu upon mu. Okay, that was very easy to write, I think. There is nothing very specific about it. But can we find some relation between lambda and nu also? Let us see. If this is nu C, and you can see this A and P, and we may call this some point, this is going to be a parallelogram, because this side is parallel to this and this side is parallel to this. Okay, so we can say this point P to this here will be nu times C. Okay, and because these three sides, let me call these points as I have not used D, P has been used, M has been used, so DPM will be similar to the big triangle ABC. So here, if it is nu C, so corresponding sides will be in the same ratio. So I can call this as nu times A here, because this is parallel to BC. And here PMC, let us call this as E point. So this will again be forming a parallelogram. So this length will also be nu A. Okay, now let us use this mu B also similar this way. If this is mu B, I think this will be mu B, because this is parallelogram. Again, PLE is similar triangle to ABE. So I think this length here LE alone will be mu times A, mu times A. So from this, what we can conclude from the diagram, that this lambda plus mu plus nu will be equal to A. And now how I am going to make use of this thing, not A, it is actually 1. It is actually 1, because A will be common and it will be cancelled. So lambda plus nu will be 1. Now what I can do, this is what we are looking for. So 1 minus lambda, I can write this as mu plus nu upon lambda. Then 1 minus mu, I can write this as lambda plus nu upon mu into 1 minus nu can be written as lambda plus mu upon mu. Okay, now all these quantities involved are positive. Okay, so here I think we can use AMGM. You can see this mu plus nu will be greater than or equal to 2 root mu into nu. Okay, similar to this, others also can be written. So if I use AMGM in the numerator, we will get 2 root mu into nu. Next one, 2 into lambda into nu. And next one, 2 into lambda into mu. And whole divided by lambda, mu and nu. So you can check, this ratio comes out to be greater than or equal to 8, because all lambda, mu, nu will get cancelled. And this equality will happen, but that means this minimum value will be equal to 8 only if you can check this lambda, this mu is equal to nu, nu is equal to mu is equal to lambda. That means they all will be 1 by 3, 1 by 3, 1 by 3. So maybe this P should be such that all lines passing through it divides these sides in the ratio 1:2 on the corresponding sides. Maybe this nu will be 1/3, so this NB will be 2/3 times C. So this is how if we place our P, we will get the answer. I think this P will be 1/3 here, 1/3 here. I think it is not centroid, because if it is centroid and if you're drawing line like this, if it is not, let me do it on the next question slide. If suppose it will be centroid, okay, suppose it's a centroid, that means line passing through G, it will be 1/3 here and 2/3 here. Yeah, so that is wrong actually, because G, if you join with AD, so 2 is here, 1 is here, so it will be 1/3 here, 2/3 here, but we are getting it opposite. So to get this minimum value, this P will be not like this, it will be otherwise. Okay. Now coming to next question, that is question number 3. Here we are given that in triangle ABC, altitude CD is 7 and AE is 6. E divides BC such that BE ratio EC is 3:4. So first I will like to write this EB as, because opposite to A, this complete BC is A. So I can write this as 3A/7. And here I can write this as 4A/7. And AB is equal to lambda root 3. We have to find what is the lambda. Maybe some integer answer or some numeric type answer it will be. So here there are 2-3 ideas which are coming in my mind. First of all, if I take some tan or sine for this angle B, we can see there are 2 right angles AEB and CDB which are involving the same angle B here. That can be the one idea. Okay, let us first do this one. Okay, so here if I take tan B, okay, so what will be my tan B? If you look at it, it will be AE upon EB, and AE length is 6 upon EB is 3A/7. So we will be getting this as 14/8. But this tan B is also, if I use another triangle, where it will be CD in the numerator upon DB in the denominator, and DB can be written directly by use of Pythagoras theorem, because this BC length is A. So I can write this as A square minus CD square, that is 49. So these two things we are getting by equating 2 values of tan B. I think that should be sufficient enough to get us the length of A. So here if I cancel this 7 with this 14, so here it will be 2 only, and then do the cross multiplication and squaring, we get 4 into A square minus 49 is equal to A square. So from this 3A square will be equal to 4 into 49. From this we will be getting A is equal to 2 into 7, that is 14 upon root 3. So this is what we are getting for A. Okay, now we are supposed to find the length C, that is length AB, and to do that, I think just a simple Pythagoras theorem will do, isn't it? Because this AB, that is C square, AB square, that is C square, will be AE square, I think 36, and plus EB square, and that is 9A square upon 49. I think very simple question, isn't it? So 36 plus 9A square upon 49. So we can write this as from A square it will be 14 square, so 49 will be cancelled. So I think we will be left with 9 into 4 here upon 3 here. So this 3 will cancel it 3, so it becomes 48. Yeah, 48. So C comes out to be 4 root 3. 4 root 3, hence lambda will be equal to 4. So that was one idea. I think that is very easy. There is another idea here also. Please see what exactly it is. I was thinking of that these points A, D, E, C are cyclic. A, D, E, C are cyclic. Okay, because you can consider AC as a diameter, and then this circle will pass through D and E because there is an angle 90 degrees subtended at D and E. Okay, now this circle, if you think of, you are drawing to secant through B, which will be meeting this circle at DA here and EC here. So this rough diagram, if I draw for the circle, it will be something like this. So using the property of secant, we can say that length BE, which was 3A by 7, and complete BC is A. So if I use the power of B or secant theorem, it will be 3A by 7 into A till C point, and that will be equal to BD. And BD we are not aware, but we can use this Pythagoras theorem for BD, which will be here A square minus the CD square, that is 49, and into this will be BA, complete length, so it will be equal to C here. Okay, so that is one equation. And to eliminate C, I think we should make use of this Pythagoras theorem only, that AB square, that is C square, will be equal to AE square, that is 36, plus EB square, that is 9A square upon 49. So I can do the squaring here, and I will be getting 9A power 4 upon 49 is equal to A square minus 49 into C square, which is 36 plus 9A square by 49. And here you can see that power 4 term will be cancelled as it is, because 9A power 4 upon 49 is both sides, so it will be cancelled. So using this also you can check, you will get A square as same thing, that was 14, that is 196 upon 3. And then we have to find C square, so make use of this A square here, we can find C square from this also. So this is another idea in which I am using the power. So this way also it can be done. In fact, there is one more quadrilateral, that is cyclic. If you can notice, I think it is if you call this point as say H, because it will be orthocenter, and we normally call this thing as orthocenter. So this HDBE is going to be cyclic. It's cyclic. And if that is cyclic, so from C or A, by using the power method, it can be done using this also. Okay, Chali, let us move to the next question. That is question number 4. We are given that in the adjoining figure, AC length is equal to BC length, and angle ACB is 96 degree, although it doesn't look so, but this is 96 degree. Okay, if ACB is 96 and AC is, that means B, and BC is A, that means big angle B, will be equal to A. So these two angles will be same, and already this angle C is 96, so this A plus B has to be equal to 84, and because A equal to B, so this will give A equal to B is equal to 42, and D is a point inside, and ABC such that inside ABC such that DAB angle is 18. So here this angle is 18 degree, and we are given DBA as 30 degree. DBA as 30 degree. If these two angles are like this, and because angle A, complete angle is 42, so here we will be left with 24. 24 plus 18 is 42, and here it will be 12. And we are supposed to find the angle ADC. So let us call this angle as X. In fact, this angle is also known to us because this is third angle of this triangle, where two are 18 and 30. And let me call this angle as Y here. Okay, now I am going to use sine rule to solve this further. We can write sin X upon AC. Sin X upon AC is equal to sine 24 degree upon this DC. And similar to this, in this triangle, sine Y upon BC is equal to sine 12 upon CD or DC. I think these are very natural choices to use sine rule. Okay, and now you can see AC is equal to BC and DC is equal to DC. That means if we divide them, we will be getting sine Y upon sine X is equal to sine 12 upon sine 24 degree. Okay, now we have to find X, and we know that X plus Y is equal to 360 degree minus this angle, and this angle is how much? I think 180 minus 48. You can check, because these two angles are 40, sum of these two angles is 48, so this remaining angle will be 180 minus 48. So here X plus Y will be 360 minus 180 minus 48, so it will be actually equal to 180 plus 48. So I will now put Y in terms of X, and we will get this Y as 180 plus 48 minus X. So this can be written as minus of sine 48 minus X whole divided by sine X. I think now it should be solvable. Here I can write this as 1 upon 2 sine 12, cos 12 actually. Sine 24 is cos 24. So here sine 24 will be 2 sine 12 cos 12. Sine 12 gets cancelled. So 1 upon 2 cos 12 here. Now I will make use of this thing in the next slide. Yeah, I have to use next slide here. So what we have got in our previous slide, I can write this as sine of X minus 48, removing that negative sign and changing the sign of angle also, upon sine X, and this is equal to 1 upon 2 cos 12. Okay, now if you open it by sine A plus B formula, sine A minus B formula, here we will be getting cos 48 because sine X will be cancelled, minus then it will be cot X into sine 48, and this is equal to 1 upon 2 cos 12 degree. Okay, so from this we get cot X to be equal to, I think this will go that side, and here we will get cos of 48 degree minus 1 upon 2 cos 12 degree, and this whole divided by sine 48. Let us see if some standard angles can be obtained from this or not. So if I take LCM here, 2 cos 12 degree, here it will be 2 cos 48 into cos 12 minus 1, and I can write sine 48 also here. Now using 2 cos A cos B, in numerator we will be getting cos A plus B, that is cos 60 degree, and plus cos, I think 36 degree minus 1 whole divided by 2 cos 12 into sine 48. I don't think if I use 2 sine A cos B, it will be any helpful, because we will get one angle as 60 but other will be 36, or let me think, we will get sine 60 plus sine 36. I don't think it will be helpful, but here sine 60 minus 1, cos 60 minus 1, please think of it. Cos 60 minus 1 is actually minus cos 60, isn't it? Because cos 60 is 1 by 2, so it will be minus cos 60, you can check. Okay, so what I can do, I can write numerator as cos 36 degree minus cos 60 degree. Okay, and again using the formula of cos C minus cos D. So this cot X here would be equal to 2 sine c plus d by 2, that is 48, into sine d minus c by 2, that is I think sine 12, upon here it is 2 cos 12 into sine 48. So the sine 48 gets cancelled, 2 gets cancelled, and this becomes tan 12, which I can write also as cot 78. Okay, hence this angle x, this was the angle x which we are looking for. Let me use this space. So angle x is equal to 78 degree. Okay, actually it can be some other angle also, but I don't think that will be possible inside this thing, because that next angle will be obtained when we add 180 to it. So that will not be possible here. So x is 78. So if we need to find with the greatest integer value, so 17 4s are, I think answer will be 4. 17 4s are 68, 17 5s are 85. So answer is definitely 4. Okay. Now coming to the next question, very interesting question, question number 5. We are given that ABCDE is a convex pentagon inscribed in a circle of radius 1 unit, where AE is the diameter. We are given AB as A, we are given BC as B, we are given CD as C, and this DE as D. Then what is the maximum possible integral value of A square plus B square plus C square plus D square plus ABC and BC and BCD. Okay, now this is little awkward, I will say, to think of such idea, but if you if you struggle with this question, maybe after 2-3 iteration you may get that if we add A to C and C to E and then use the Ptolemy theorem. Okay, using Ptolemy theorem, we will be getting something very useful for this result. Please see what that could be. If I use this quadrilateral, let me use ABCE. Okay, so using this you will be getting that AY into plus 2 into B, and that will be equal to x1 diagonal into BE, and BE can be written as, if you join B with E, you will be getting that can be written as root over 4 minus A square. BE can be written as 4 minus A square. Okay, now similar to this, if I use instead of ABCE, let me take from this side, so EDCA, yeah, EDCA if I take, then here it would be x into D and 2 into C, and that will be equal to y into the diagonal here will be AD, and I can write this as y into root over AD would be 4 minus D square. Okay, so these are two equations, 1, 2, and also from this diagram it is very much clear that x square plus y square is going to be 4, because this angle is 90 degree as this AE is diameter. Now if I square and add, if I square 1 and 2 and add both sides, so what I am going to get here, a square y square plus 4b square plus 4aby plus the second one would be x square d square plus 4c square and plus it will be 4cdx, and on the right hand side it will be, you can check, after squaring 4 can be taken common, x square plus y square minus x square a square minus y square d square. If you do so, and if you bring these x square a square term on the right side, on the left side actually, and not this, I will combine this a square x square with a square y square, so that I can make use of this x square plus y square equal to 4. So if I bring this here and if I take a square common, okay, I can write it directly, or yeah, I think I can write it directly, because a square common, y square plus x square. Similarly, we are having 4b square, we are having 4c square, and then if you take this x square d square along with this y square d square, where I will take d square common, and once again x square plus y square will give us 4. And then what are the other terms that are remaining? I think 4aby plus 4aby plus 4cdx, and that is coming out to be equal to 16, because x square plus y square is equal to 16. I think we have taken care of all the terms here. So here we can check 4 is coming common, so I can let me take next slide to do the remaining calculation. So what we have got after taking 4 common here, that a square plus b square plus c square plus d square plus aby plus aby plus cdx plus cdx, and that comes out to be, after dividing by 4, is equal to 4. Okay, but if you compare from this, we get ABC, and here it is aby instead of C. Similarly, we have CDX instead of CDB. So instead of X, we are having B. Now, everybody listen carefully. As this angle is obtuse, and this angle is also obtuse, isn't it? So if these angles are obtuse, we can very easily say that this X is going to be, X was replaced by B, na? So X is going to be greater than B. X will always be greater than B. And similarly, Y will be greater than C. Y will be greater than C. So here you can check this A square plus B square plus C square plus D square. These 4 terms are as it is. Only these 2 terms, ABC plus BCD, they are different from this. So if we write Y in place of C, and we write this X in place of B, X in place of B, then I think this expression here will become lesser. So this will be strictly less than 4. Okay. Now, one can think of that if I make some situation like where DE is almost becoming, tending towards 0, where D will be very much small. In that case, this ABCDE will not be a pentagon where D will be merging with E, it will just be a quadrilateral. And in that case, it can be checked that Y will become equal to C. Okay, and in that case also Y will become equal to C and D will become 0. Yeah, so in that case Y will become equal to C. So what change we have done here, this will be nullified and D will become 0. So this term in both terms will become 0. So in that situation, if your D becomes approaching towards 0, I think this expression can become equal to 4, but in limiting case. I am repeating, if D tends to 0, then Y will tend to C. So these two expressions will become same, but it is only limiting case. So it cannot reach to 4. It can reach to 4 only if D becomes equal to 0, but then it will not be pentagon. So if maximum possible integral value we are looking for, it will be 3. It cannot be 4. It can be 3 only. In fact, it can be checked for other values, that values lesser than 3 will be possible. You may take some other pentagon here. Its length, this AE is 2. So taking A, B, C, D all equal, it can be checked that 3, this value will be lesser than 3. Just 1 minute. Yeah, it will be lesser than 3. So the maximum possible integral value will become equal to 3. It can be checked. Just 1 minute. Let me think. Just 1 minute. Actually, we are supposed to find maximum value, not the minimum value. So I cannot comment when it will be minimum because I have only found the maximum value. So maybe when all A, B, C, D are equal, it may be minimum. So let me see. Actually, this complete angle is 160. So if 1, 2, 3 sides are forming equal angle, so there will be 140. These angles will be 45, 45, 45. So if A is equal to B is equal to C is equal to D, all these sides will be forming angle 45 here. This will be 45, and in that case, because this is 2, I think A will be equal to A will be equal to, because this will be 1, not 2, sorry, because radius of circle is 1 only. So if this is 1, so this angle will be 45 by 2. So sine 45, I think, no? If this is 45, yeah. So A will be 2 sine 45 by 2, 22.5. Okay. So if we take all A, B, C, D equal, they all will be equal to this thing only. Okay, so here it can be checked for A square plus B square. I think it is going to be calculative. Yeah, I have got one idea that will be easier. Please think of it. If I take, let me take another slide first. So my idea here is that if I take this B almost at E, this B almost at E, and all these 2 points C and D are taken here only. Okay, so you can see in this case all the sides except A. So this A will be almost equal to 2, B, C and D, they can be thought of that tending towards 0. B, C, D can be thought of tending towards 0. So in this case, if you think of this A square will be 4, yes, others will be 0, 0, 0. So again, I think we are tending towards 4. Okay, so saying that it will be less than 3 or not, it is not very obvious to say, but one thing is clear, that I think they are talking about maximum possible of integral value, maybe GINT value they are talking about. So that will definitely be 3. So that is how I think we can conclude this question. You may try with when A, B, C, D all will be equal, whether this sum can become less than 3 or not. It is not looking like that. Okay. So I think I'll conclude this question here with this possible integral value only by not taking minimum value, but it can be checked. I will leave this for you to do it. Okay, or maybe in the next session I will try to get the solution for this part also. Okay, now coming to next question, that is question number 6. It says triangle ABC has integer sides. Angle A is 2 times B. So if this angle is B here, this angle is 2B, and angle C is greater than 90. So we have to find minimum length of perimeter of triangle ABC, and sides are all integers. So maybe we will make use of some number system concept here. So first of all, as angle C is greater than 90, so this side length C square has to be greater than A square plus B square. Okay, we will try to write as many results that we can write easily, so that if we have to put some values, we will have certain degree of freedom that we can neglect this or that, so that we will jump to the conclusion quickly. Now we are given A is equal to 2B, so using sine rule, so I think we can write this as sine 2B upon A. Sine 2B upon A is equal to sine B upon B. And sine 2B formula if I use, we will get cos B is equal to, I think, A upon 2B. A upon 2B. Okay. Now from this we can conclude that A is going to be lesser than 2B. Here this B has to be acute because C is obtuse, so this cos B will be positive. So A has to be lesser than 2B. I think this is also going to be very important result. Let me call this as 3. Okay, now what else we can do? I think using cosine rule may help here. I can write cos B as A square plus C square minus B square upon 2AC will give us equal to A upon 2B. So let me cancel this 2 at least here. And if I multiply by B, both sides, we will get A square B plus C square B minus B cube is equal to A square into C. I think we are getting some factors here. Please check what are they. A square minus B square into B. If I take these two terms together, and this is equal to, I can take C common here, and here it will be A square, not this way, let me just think. A square common, so B minus C, yeah, I think I should take A square common, not this thing. Here if I take A square common, we will get B minus C. I am taking this term on the left hand side is equal to, if I take B common, then it is B square minus C square. So B minus C is cancelled because B cannot be equal to C from this relation also. So we will get A square is equal to B into B plus C. Okay, so here you can think of, you can see that this B should divide A square. This B should divide A square. All these sides are integer, so B should divide A square. Now this is one important result, but this also has one very important thing. Please listen carefully, that B cannot be prime. Why I am saying so? See, if B is prime, suppose B is equal to some P, and this divides A square, then you can think of A should also be K times P, isn't it? If B is some prime number and that prime number divides A square, so this prime number should also be there in A, then only this P will divide A square. Okay, so this A will be equal to KP, and from this equation number 2, this cos of B will become equal to K. Okay, and here K has to be at least 1, okay, or larger. I think greater than 1 is just out of question, and equal to 1 is also not possible because cos B will become then 1, B will become equal to 0 degree. So that means B cannot be prime. I think that is also something we should keep in our mind. In fact, one more thing, B can also not be, B also cannot be product of 2 primes, just product of 2 primes. Same logic, product of 2 primes. Why I am saying so? Suppose you take, let me do this calculation here, if B is equal to 2 primes, P1 and P2, okay, and they divide A square, then A should have both the primes in it, P1 also, P2 also, and some other integer will be multiplied here. So once again with the same logic, cos B will become equal to K. So again, B cannot be product of 2 primes. I hope you are getting it. If B is product of 2 primes, P1 and P2, and that divides A square, so this P1 also be the factor of A, P2 will also be the factor of A. Without A having P1 as a factor, P1 cannot be a factor in A square. I hope you are getting it. So these things I will summarize in our next slide, where I will start putting the values. So this is what we have got so far. I think there is one more thing that I can do here. Let me use this relation. Let me call this a 3.1 because I have already used 4. So using 3.1, what you can do, we are getting A square minus B square is equal to A square minus B square is equal to BC, is equal to BC. So I'll write C here, I will put B here. And now if I do squaring both sides, we will get A power 4 plus B power 4 minus 2 A square B square upon B square. and this is equal to c square. But we write in the beginning that c square is greater than a square plus b square. So dear all, please see this b power 4 upon b square. This can be cancelled with b square here. So we will be left here with a power 4. We will be left here with a power 4 minus 2a square b square, and let me write this as greater than or equal to a square b square, because this b power 4 upon b square and this b square term will be cancelled. Okay, so here we are getting this a square to be a power 4 actually is greater than 3a square b square. So from here we get a square will be cancelled, a greater than root 3b, and this is one very important thing here. That's why I have done it, that a is less than 2b but a is greater than root 3b. So a is less than 2a, a is less than 2b, a is less than 2b but greater than root 3b. So this is what we are getting. And dear all, because a, b, c are integer and root 3 is 1.732 and 2 is very much close to that, this result is going to help us in many I will say in very great way. So let us first summarize what exactly we have got so far. One thing is here that I have clubbed there also. So yeah, so I will use this as, let me call this as Roman equation 1. That is one thing I am going to use. And then we found that b divides a square. B divides a square, let me call this as 2, and I also said that b cannot be prime or p1 p2 or p1 p2 p3 like that. Okay, otherwise this relation cos b equal to a upon 2b will not be possible. Okay, I think that should be sufficient enough to do this. Now please see, if we have to find the minimum length of perimeter, and if I start putting the values, okay, so because 2 and root 3 is 1.732. So in order to get an integer between 2b and root 3b, I think I should take b from 4 only. You can check. 1.732 into 4 will be lesser than it will be lesser than 7, and 2b will be 8. If I take this thing, 2b will be 8 and root 3b will be equal to 6.8 something. So here there is a one integral value that is possible, a is equal to 7. If you take b to be 3 or 2 or 1, you can check between root 3b and 2b there cannot be any integer. Let me put it here. If b is 3, okay, then 2b will be 6 and root 3b will be 5.1 something. So you can see between these two there will not be any integer. Okay, but here for b is equal to 4 also you can check. We want b to divide a square, that is not possible. So this is also ruled out because of this second one. Okay, so this way we will keep doing further. But taking b is equal to 5, I think I should not consider because b cannot be any prime. Next I will be taking 6, but I think 6 is also 2 into 3 types. So this is also not possible from that hypothesis. So 7 is also ruled out. 8 can be taken. 8 can be taken. If I take b as 8 and if I multiply 8 by 2, so it will be 16, whereas it will be 17 into 8 is I think 13.6. So a can be 14 and 15. Two values are possible. But in this case also b doesn't divide a square. So this b is equal to 8 is also ruled out. We can check for b is equal to 9. In that case also, you can check 2b will be 18 and root 3b 17, 9s are 15.3. So here we can take this as 16 or 17. But again b does not divide a square. So this is also ruled out. So what are the other possibilities? I think b is equal to 10. We should rule out immediately because it's a product of two prime numbers. And b is equal to 11 itself is a prime number. B is equal to 12. It is 2 square into 3, so there can be chance that we may get something from here. Let me go to the next slide. So far we have gone till B equal to 11. Now if I take B is equal to 12, okay, so our condition was A will be greater than root 3B, but it will be less than 2B. It will be less than 2B. So 2B is 24. 2B is 24 in this case. And how much will be B into root 3? B into root 3 means 12 into 1.732. Okay, so 12 into 17, if we do, it will come out to be 12 sevens are 84. If I ignore 32 here, so 84 and I think 20.4 something. Yeah, 20.4 something. So in this case, my possible value of A can be 21, 22, 23. But once again, I want that B should divide A square. That is not happening here also with these values. Okay, then B is equal to 13 should be ruled out because it's a prime number. B is equal to 14 should be ruled out because it's 2 into 7. B is equal to 15 also ruled out because it's 3 into 5 product of two prime numbers. Okay, so what is now next number? B is equal to 16. And if I take B is equal to 16, my 2B will be 32. Okay, and root 3B, that is 16 into 1.7. So it can be around, if I ignore 32 in the end, so 16 sevens are 112. Yeah, and 16 plus 11 is 27. So 27.2. So the possible values could be A is equal to 28, 29, 30 and 31. You can see as value of B is increasing, we are getting more and more values of A. And here this B, which is 16, is going to divide A square also. So here it seems like we have got the number which we were looking for. A is equal to 28, B is equal to 16. A is equal to 28 and B is equal to 16. Okay, and let us check if any other condition we are missing. I think I have already summarized all the required conditions in 1 and 2. So anything else is not required. C can be found from this result. A square minus B square upon B. So C I can write as A square minus B square upon B. Yeah. So let me write this as A plus B. I think it will be 44. 28 plus 16, 44 into A minus B, that is 12. Upon B is 16, and this C should also be integer. So it is 11 here and 3 here. So 33 we are getting. So we have got all these values A, B, C. So least perimeter, because I started with B is equal to 2, 3, 4 and so on, and this was the first value which we got as the answer. So here we are getting 28 plus 16, that is 44. 44 plus 33 is 77. So 77 will be the answer for this question. Very interesting question. In fact, there can be many more values as you keep increasing values of B. You may try for second highest, second least perimeter, means after B is equal to 16, what will be the next value of B which will be satisfying all these values. Okay, so this completes this question. Now I'll come to the teaser question, but before that, everybody, let me talk about Vedantu Eklavya. If you are going to prepare for JEE Advanced, then this is one very big thing in online domain. It will help you to prepare for JEE Advanced on online system in very big way. Just Google it, you will come to know what exactly Eklavya is doing. Okay, now I am sharing with you this link for notice board of Topper Pod, and this is the QR code for the same. This notice board is having all important information about new batches coming up or new things going on in these batches. So please follow it and see if anything of your interest is happening there. Now, if you are going to write JEE Advanced in 2023, I'm sharing with you the link for Telegram channel, and this is the QR code for the same. We are putting all important informations there. Just follow it and you will have all relevant information there. Okay. Now, same thing is for those students who will be writing JEE Advanced in 2024. Dear all, we have created one V-Impact channel where we are putting solutions of JEE Advanced, KVPY, ISI CMI. ISI CMI are in the process, and we have put all the solutions question wise, and you will find alternate solutions also. So do visit it and follow it. Okay, so you will be getting very nice solutions there. Now coming to teaser question, one very interesting and challenging problem. I will love to have solutions from you, and I will like to see how you have done it. I will like to compare with my solution. Here we are given that in a triangle ABC, P is an interior point with BC is equal to 3, AC is equal to 5, and BA is equal to 6. Okay, I think triangle is possible. Yes, it is possible. Now there is a point P. Perpendiculars PA dash, PB dash, and PC dash are drawn to the altitudes AD, BE, CF such that AA dash is equal to BB dash is equal to CC dash. We have to find the length AA dash. That is a question. Okay, I'll give you bonus if you can find AP also. If AP is found, I will give you bonus, double bonus, or whatever you think of. Bonus if AP is found. Okay, so that is all for today. Yes, if you have solved it, do not forget to send your solution to eklavyasupport@vedantu.com with subject line teaser solution maths. Okay, we will check your solution. If we like, we will reach out to you and we will contact you, and we would like to be part with us. Okay, and that is all for today. Thank you so much. Take care. Bye everyone.